Alrighty, so same idea, different set of values. So now, again, we only have 3 inequalities, but I want to point out that these last two are double inequalities. And all that means is there's 2 inequality symbols. Y has to live between these 2 numbers, X has to live between those 2 numbers. Other than that, same exact idea. And then just like last time, we're looking to maximize. This is the same type of question, same group, right? So we're looking to maximize. And again, I am going to highlight our value here just so we don't forget about it. You want to remember this step, right? Okay, let me bring in our graph. Very similar to last time, I'm going to work on some values. I'm going to get them kind of written down. And then we will work on getting that graph looking nice and beautiful. Okay, so first up, 6x plus 8y is less than or equal to 48. So x-intercept means y is 0. So that's 6x plus 0 is, we'll put equal to 48. 6x is 48, divide by 6. X is equal to 8. So that's the ordered pair, 8, 0. And then you've got your y-intercept, which is when x is equal to 0. So that's 0 plus 8y is 48. Divide, and you've got y is equal to 6. So that's 0, 6. Now, these other 2 values, or these other 2 inequalities, like I said, they are strictly, they're going to be straight lines. So they're strictly y lives between these 2, x lives between these 2. I would encourage you to think of them almost like number lines. In fact, let me do the bottom one first. So let me go a little out of order. 0 less than or equal to x, less than or equal to 7. If you thought of this on a number line, right, if 0's here and if 7's here, and I'm using closed dots because there's brackets or equal to's here, you could use brackets as well, x has to be between them. Well, where do you see that happening? It's happening here, right? So that's actually what we're representing. We're shading everything that lives between. Similar to that, our second one, we've got y is between 0 and 4, but y is a vertical line like this, right? That's the y-axis, I mean, right? And so if you put 0, I'll put my closed dot again, and 4, again, where is y between that? Well, it happens in between those 2 numbers. So I'm going to graph, and I'm going to keep those 2 pieces in mind. So I'm going to start using my my first inequality. So we have 8, 1, 2, 3, 4, 5, 6, 7, 8. And we've got 6, 1, 2, 3, 4, 5, 6, right? Again, I'm graphing like this. I'm using the first quadrant because y is greater than or equal to 0 and x is greater than or equal to 0. And both of those things tell us we have to be in the first quadrant, okay? So that is one graph. So we've got a point here, and we've got a point here. It's one line, excuse me. And I'm going to connect those dots. And then as we look at our other 2 values, x is between 0, so here, my ruler out of the way. So here, and 7, which is here. 7, right? Let me put 0 there if you want. So that means any x value between those 2 is fair game. Now, what I mean when I say that is we're actually thinking of these 2 as 2 vertical lines. So I know in the last one I said I didn't need to graph it again. I'm going to do this one for emphasis so we can see exactly what I'm talking about. So here is one line. And these both extend forever up and down, this and like this. And our correct values for x live between those two. Do you see how it kind of cuts off this end of our graph over here? Right here, it kind of cuts it off. We'll come back to that and adjust if we need to. Y has something similar, but this is going to be horizontal. They're going to be flat. And that's going to be between 0 and 4. So again, here is 0, 1, 2, 3. Here's 4. And label it as 4 right there. Okay. And our ruler, we're going to draw lines between, or that represent those as kind of boundaries. So as we look at this, again, it's slightly different, but these straight lines are really helpful. They really help us see what our values are here. So next, what we would want to do is we would want to pick some test points. So again, remember we said for the last two, so our third one, it's the values in between. So between here and here. And for y, again, it's in between, so it's the values between here and here, right? That's between 0 and 4. We really only have to do a test point for that first inequality. 6x plus 8y is less than or equal to 48. That's our first one, right? So if we plug in 0, 0, that's 0 plus 0 is less than or equal to 4. 0 is most definitely less than or equal to 4, so true. So we shade below that line right there. And this is where drawings, and you have to be very, very careful, very, very clear of what you're talking about. In fact, I'm going to go over this with green, right? I only go this high, right? I stop at that 4 because y has to be between. I come backwards this way. I come down from here. I don't finish that little point. It actually turns right there. And then this bottom part. So you have this really strange, like this kind of a shape. And we're talking about everything inside of that. So hopefully you can see that. Hopefully that shape and that kind of design of it makes sense to you. What we need now is we need our corner points, right? And I actually might even use my little, let me draw my sketch over here better. We can use kind of that to stand in, because our picture is a little small, it's a little tiny, right? So if it gets kind of hard to read, just do another sketch, right? We're not tied to that one. So again, we have this back line, it's flat across, it drops down, it's down there. Mine might be a little exaggerated, but we have these corner points. So there's 1, 2, 3, 4, and 5, okay? Some of these we know automatically, like this bottom point, I'll put a pink one here. This bottom point, we know that is definitely 0, 0, because it's at the origin, right? We also know this point up here because we used it to graph, right? So that's 0, 4. Same goes down here at this point because of this vertical line, right, for x. So that's 7, 0. Now the ones that are a little less clear are these two kind of top remaining points, right? So again, which two lines intersected to find that? Well, this one is y is equal to 4, and that's intersecting with our first inequality, right? This 6x plus 8y less than or equal to 4. 6x plus 8y less than or equal to 4. So we could just set those equal to each other, right? Remember, we're treating it as a system, 6x plus 8y. You could put equal to, that's fine. 4, that's 48, excuse me, 48. And y is equal to 4. But think about that, right? We already have a y value, so just plug it in. 6x plus 8 times 4 is 48. 6x plus 32 is 48. Move the 32, move the 32. 6x, that's a 6 and a 1. X is equal to 16 over 6, which is going to be 8 over 3. And sometimes we get those just ugly looking answers, and that's okay. So that is the ordered pair. We found that top point, right? That's the ordered pair. 8 over 3 and 4. And we're going to do something similar for this last point. So again, that's our first inequality. So that's 6x plus 8y less than or equal to 48. And the bottom point, remember, we're looking at where it intersects this line. Well, that line is x is equal to 7, right? So again, just like last time, you have the x value. Plug it in for x. So 6 times 7 plus 8y is 18. 6 times 7 is 42. Plus 8y is 48. I don't know why I keep writing other numbers, but 48. Move that 42 over. I got suspicious because it shouldn't be negative. It's graphed as a positive. 8y is going to be equal to 6. Again, it doesn't go in evenly. Divide, y is going to be 4/3, but that's okay, right? So x in that case was 7 and y was 4/3. This gives us 5 corner points to work with, which is fine. We can handle 5 corner points, right? Corner points. Now, I want to emphasize, even if these are fractions, all you're doing is plugging numbers into them, or using them to plug in, right? We're not doing anything completely crazy and wild here. And then I'll write our objective function in a moment. So in no particular order, I'm going to start with 0, 0 and work my way around. So 0, 0, 0, 4, 8/3 and 4, 7 and 4/3, and 7 and 0, right? Maybe you want to knock out the whole numbers and come back to the fractions. Again, whatever works. Okay, so let's plug it in. This first one is lovely because you get z is 17 times 0, 3 times 0, plus 60, and that's just 60, right? 0, 0 is our favorite point. If we plug in 0, 4, you still get 17 times 0, but now it's minus 3 times 4 plus 60, which is going to be negative 12 plus 60, which is going to be 48. So again, we're trying to keep maximum values in mind here. So far, that first one's our best candidate. Z is equal to 17 times 8 over 3 minus 3 times 4 plus 60. And if I have to move my other points down to make space, then we'll just do it. No big deal. So first up, 17 times 8, I just multiply straight across. We get 136 over 3. That's not divisible by 3, so minus 12 plus 60. We know from the last question, this is 136 over 3 plus 48. What I'm going to do is I'm going to put that over 1, and I'm going to get a common denominator, so times 3 times 3. So this gives us 136 over 3 plus 144 over 3, which gives us 280 over 3, which is about 93 1/3. So again, keeping us in the frame of who is larger. It's exactly 93 1/3. So far, that's our winning candidate. I'm going to scoot these two down. This was 7 and 4/3, right? So z is equal to 17 times 7 minus 3 times 4/3 plus 60. 17 times 7 is 119. Now this one works out beautifully, right? We only had one ugly one. Those 3's cancel. This is just minus 4 plus 60. Okay? So 119 minus 4 is 115 plus 60 gives us 175. Now that's our candidate for the largest one, right? Last but not least, 7 and 0. Z is equal to 17 times 7 minus 3 times 0 plus 60. 17 times 7 is, again, 119 plus 60 which is 179. It barely wins. Do you see that? So our winner is this one right here. I better turn to a highlighter. There we go. 179 at this location. So maximum value, 179 at 17, excuse me, at 7 and 0. Now, we could have just as easily asked for a minimum value. In fact, if you look at this, who is the smallest? This guy up here, this one up here would be our minimum value. It wasn't asked for, but you could find it if you needed to. It's not bad practice. All right? See you in the next set. We're going to look at minimums next.